Thank you for coming and attending this session. You've chosen the best session at Next to sit in on. My name is Joe Kava. I'm the Vice President of Global Data Centers at Google. What that means is that I help to lead the teams that are responsible for the end-to-end life cycle of our data centers, from the very beginning stages of site selection and location strategy to procuring all of our energy contracts, including our renewable energy, to design, construction, and full operations of the data centers all around the world. I've been at Google just over 11 years, and I've had the pleasure of working with amazing people and seeing incredible technology evolve. So today, I'm going to try and give you a little bit of an insider's view into our data centers, what makes them special, what I really appreciate about our data centers, and as a clue, it has a little something to do with sustainability. You probably saw this on your screen as you entered the room. We're using a tool, first time at Next. It's called Dory. It's an internal tool that we use at Google for all of our large meetings like this. So feel free to open up the tool on the app, and you can submit questions and upvote other questions. And I'm going to try and leave time here at the end so that we can address them, and we'll also have mics open for live questions if you'd like. Okay, so let's start with a little bit of an examination of what do you need from a data center. Well, if you're like me, and I suspect most of you are, you need your data center to be very high performance. You need it to be highly available. You need it in places where you need to be. You need it to be extremely reliable, needs to be ultra secure, and if you can wrap that up with a bow of sustainability, then you've got something that is truly meeting all your needs in a data center. Since the earliest days of when I got to Google, and actually long before I was there, for about 2 decades now, Google has been the leaders in ultra-high performance computing systems. One of the things that impressed me when I first arrived was that even as innovative as the data centers were, I remember the very first day that I was at a Google data center, and everyone kind of wonders what a data center is like at Google. I did too. When I got there, I was kind of tracing the path of the electrons in my mind, and I was just shaking my head, and my manager asked me, is something wrong? And I said, no, it's just so obvious. I don't know why everyone isn't doing it. But what impressed me most is that no matter how good we're doing, we always believe we can do better. So we have a relentless focus on innovation and constant technology evolution. So ultra-high performance, what does that mean? Well, for us, it means that we don't rely on just off-the-shelf components. We design and build almost every part of the stack custom built for us for ultra-high computing, ultra-high efficiency at the price and performance that we need it to be. So this is everything from our custom designed high voltage substations that are on the campus of all of our data centers, to the servers themselves, the racks that the servers go in, the custom designed cooling solutions that those racks mate to even the way we operate the cooling plants. I'll touch on that a little bit more, but as I mentioned, it truly is just a relentless focus on continual improvement and constant innovation. So as I mentioned, these are built for Google. There's no unnecessary components in our servers. They're stripped down, just ultra-high performance computers. This reduces vulnerabilities. As you know, we have a very, very strong focus on security. So all of our servers have our built-in Titan chip from the time that they're manufactured for us to our specifications. And that Titan chip is helping to secure every server throughout its entire life cycle at Google. All of our services are dynamically allocated. We talk a lot about this, our Borg system, which we have been using internally at Google since the earliest days, that eventually became the orchestration layer for all of our containers. And so we are constantly provisioning and upgrading and redoing our infrastructure. Since we're constantly upgrading and changing, it has to be very flexible and adaptable. So we put a high priority on optionality. I'll talk a little bit more what that means. It has to be extremely efficient, ability to scale, and our data centers also are compliant with the Open Compute program, the racks that are available through that. So why is that important? Well, it just means that we're leveraging the rest of the data center ecosystem as well, not just relying on what we do. We also have our own teams that are staffing the data centers. In particular, our hardware operations teams that are there 24/7 at our data centers. They're doing all of our deployments, maintenance, upgrades, repairs of all of the hardware, all the servers, storage, and network in the data centers. They're there in real time, so they respond very quickly. They have all the tools necessary to make their job very efficient, and they are highly reliable and do this all the time. So we're not relying on an SLA with a service provider to come in and service the data centers. We do that ourselves. Since I've been at Google, we have constantly been innovating in cooling. Why is that important? Well, data centers consume a lot of energy, and in a data center, one of the largest overhead components is related to the air conditioning or the cooling of the data center. So we have innovated our cooling systems about every 18 months since the time that I've been at Google. We've used a variety of cooling techniques. We use seawater in Finland. We bought a paper mill, turned it into a big data center campus, and it actually was sitting right on the Gulf of Finland. So we were looking at that water that was about 14 degrees Celsius all year round and said, we can use that. So that data center is 100% cooled by seawater. We use reclaimed and stormwater in a data center in the southeast of the United States. We built a stormwater capture and reuse system, so we're cooling the data center with stormwater there. In Belgium, we're sited right next to a big industrial shipping canal, so we use the industrial shipping canal water. Kind of the point is, you see where I'm going with this, we don't have a cookie-cutter design. We don't have a one-size-fits-all model. We optimize the designs of the data center for that specific location, for the environment that it's working in, to make most use of the natural resources that are there. Okay, so that's what you need from a data center. But you also have to consider where the data centers are. You need them in the right locations. They have to kind of meet you where you need to be. So we have a very large footprint of data centers. We have 16 global campuses. When I talk about a campus to us is typically hundreds of acres with many buildings, many data center buildings on each campus, all connected by one of the world's largest, most high-performance public networks available. We have 19 regions for our cloud compute. We have 58 availability zones there, 134 points of presence. We are in over 200 countries around the world, all interconnected with hundreds of thousands of miles of fiber, including 13 of our own subsea cables, making us really the largest overall compute infrastructure of any of the major players. Okay, so even long before cloud computing was a large business for us, we had been building this infrastructure for a couple decades to service our own needs, to service Gmail and search and ads and all of the YouTube and all of the Google services. So we have been building this infrastructure, and we learned how to scale, and we learned how to build efficiently for our own internal needs. What that means is that we have 8 products currently that each are serving over 1 billion active customers a day. It's a lot of learning that came with that, and all of that gets applied to Google Cloud. So they're benefiting from 2 decades of learning of how to scale, how to build, how to do things hyper efficiently. So where are our data centers? Well, we have data centers, campuses on 4 continents: North America, South America, Asia, and Europe, of course. We pick the sites based on a rigorous time-tested site selection criteria. We take input from our internal customers. Cloud is one of our largest customers now, dictating a lot of where they want to be to serve the customers and meet you where you are. So with that, we look for things that we can more or less build into for the next decade or so. So our strategy is that we want to find sites that we can be building at and building up for about 10 years or more. There's a long list of criteria. A lot of people always ask me, how do you choose a data center site? And if I were to quote the head of our site selection team, he would probably say it's more or less the art of compromise, because there is no one site that meets 100% of every single thing we would love, so we try and find the best compromise. But what that means is that we wind up, like this site here is in Belgium, we wind up with a large parcel of land that we can build multiple data centers on for many years to come, and that gives us access to our customers, gives us access to a workforce, gives us access to high-quality fiber, and more importantly, every day, gives us access to renewable energy. This particular data center is in Iowa. This is in our central region. This is the first part of the parcel that we developed. This part of the parcel is 300 acres. The overall site is about 3 times that size. If you were to measure this out, this fits about 235 American football fields on this part that's the developed part. We have another 2 parcels that we could develop that are equally this large. You'll see in the foreground here that small building, that's a 1-story data center. That building is about 1/3 of a mile long. And then behind it, you see the data center that's a little taller. That's a 2-story data center, also 1/3 of a mile long. And then the ones that you see that are being built behind that, those are 4-story data centers. Also will be about 1/3 of a mile long when completed. The amount of capacity here is staggering. And it provides a good exercise opportunity for our teams that are at the site. They can just jog around the perimeter and do about almost 3 miles of jogging just to go around the buildings right now. Okay, so you've got the what you need, you got the where you need it, but what about how? Well, you need it available all the time. If you caught the keynote this morning by Urs, he mentioned that unsolicited by Google, not commissioned by us at all, but an independent industry analyst said that by far, Google Cloud has the lowest downtime of any of the major cloud providers. That's not by accident. It's because of the way that we design, build, and operate our data centers. And when we say 7 by 24 by 365, we really mean that. The design principle of our data centers is to be fault tolerant and allow us to maintain the data centers transparent to all of you. What that means is that, look, you can hope that things don't break, but I'm here to tell you things break. When they do break, you shouldn't care because it should be transparent to you. So that means we have to do maintenance and we have to do upgrades and repairs while the data center is still live. So we build in the ability to 1, make it fault tolerant, and 2, make it concurrently maintainable. We also build in hooks. I talked a little bit earlier about our value of optionality. What that means is that we don't have a crystal ball. I don't know exactly what we're going to need from our data center a few years from now. I don't know what the latest generation of platforms that are going to be developed are. But we want to add in the hooks that allow us to accommodate for whatever our platform's development team comes up with. One example is when we built our first data centers, we didn't know about the TPU systems that were developed for our ML and AI applications. However, we were able to accommodate those, and even the latest generation that requires water cooling at the chip level, we were able to accommodate that because we had built in the hooks to allow us to do those types of things in the future. So really what the idea there is that we're looking to the future and we're planning to be able to accommodate whatever the requirements are. And from our operations team, one of our core principles is on continuous learning, continuous improvement, and what that means is transparency. If you make a mistake, you can't hide it. People make mistakes. It's okay. We have kind of a no-blame policy because we just want to learn from what happened. And it's typical in the industry that of all the data center failures, still about 70% of all data center failures today are related to some form of human error. At Google, ours are much less. It's a little bit over 15% that are related to some sort of human error. However, because of our designs, because we don't expect perfection, we design for them to be tolerant of mistakes. And what that means is that even though there were 15% of the errors that were human-related, none of them resulted in downtime of the data centers. That's also quite different from the industry average. In order to help our teams manage the data centers, we have to monitor everything. You might say that we're a little bit data obsessed. So we are monitoring every aspect of the data centers, from the servers themselves, monitoring temperatures and air pressures and flow rates, and in the mechanical cooling yard, the flow rates and differential pressures of the cooling systems. On the electrical side, everything from the high voltage substation all the way down to the server level is monitored. And of course, security. All of our security systems, all of our multi-layer security systems. So these are all monitored. Truly, we have world-class monitoring from chip all the way to chiller. And that enables our teams to understand what's going on so that they can best operate, maintain, and repair the data centers. Okay, speaking of security, data centers have to be ultra secure, and ours are ultra secure. There was a recent CBRE study that said that still one of the highest priorities in site selection for where to place their equipment in a data center is based on the security profile of the data center. So we take that very seriously. We employ a kind of a defense in depth type of a strategy for physical security at the data centers. That means that from the very outer perimeter, around a campus that's hundreds of acres large, there's already barriers and fencing to prevent people from just wandering in. And the closer you get to the data center itself, the higher the security, the more rigid the policies are. And what all this means is that out of all the data centers around the world, less than 2% of Googlers have ever set foot in one of our data centers. And that's done by design, because protecting the data and the information and the privacy of our users is at the foremost of our design criteria for the data centers. So unless you have a job that requires you to be at a data center to perform that job, you don't go to the data centers. It's just that strict. So I talked about our physical security, but truly physical security and information security have to go hand in hand. It's part of the same design criteria. However, our information security team are separate from my team. And that is done by design because, one, they truly are the world's experts in protecting information security. It's a very large team. They've been published in written books on security principles and all that. And truly, they need to be standalone. And it's also for governance. because you want the two teams to be little checks and balances on each other. So as I said, on the physical security side, we use a multi-layered strategy. To get into the data center itself, you have to have a badge that authorizes you to be there, and that's tied to your credentials, of course. Then we have biometric authentication, which is pretty typical. But then we have a lot of other layers of security that are not seen. So we know who is in the data centers, where they are. We know what they've touched, why they did it, what actions they took, so that we have complete end-to-end traceability of everything that's happening in the data centers. This is a quote from Data Center Knowledge that basically it's just summarizing what I've been saying, is that data center security measures are built into pretty much every single layer of the system, from the data center itself, the building, the security principles, the security designs, all the way down to the servers themselves and our custom security chips built into the servers. Okay, now, we know what you want, what you need from a data center. We know how you need it, where you need it. So we've covered most of the reasons, but what if you could wrap all this up with sustainability also? More and more, our customers are telling us that they have their own corporate mandates around sustainability and energy use and renewable energy purchases. So we have been focused on sustainability for long before I came to Google. We were the first company to achieve a zero carbon footprint, and I'll talk a little bit more about that. But really, our sustainability efforts are broken into three kind of pillars, if you will. Energy efficiency, because truly the best use of energy is the energy you don't use in the first place. So we've been laser focused on energy efficiency at the data centers. Second, our use of renewable energy to power the data centers. I'll get into a lot more detail about that. And lastly, our commitment to a circular environment and our philosophy of a zero waste to landfill. And I'll talk more about that as well. So as I said, the best energy saved is the energy not consumed in the first place. Google data centers are, without a doubt, some of the most efficient in the world. What that means is that compared to a traditional enterprise data center, a Google data center consumes about half of the energy that a traditional enterprise data center would. And at the same time, we're delivering 7 times more compute power at our data centers today than we were just 5 years ago. So what that means is that that's a lot more Gmail, a lot more search, a lot more YouTube cat videos, and a lot bigger cloud for the same energy footprint as just a few years ago. As a matter of fact, one measure of energy efficiency in the data centers is a very simple metric called PUE. Most of you have probably heard of it. It's a very simple ratio. It's the total energy consumed at the data center divided by the IT energy used. And so everything else is overhead. So it's a ratio that generally measures, something above 1. And most average data centers are still about 1.58. What that means is that they have 58% overhead. Our data centers have 11% overhead. And this is a trailing 12-month average across the fleet of every single one of our data centers around the world. This is not cherry-picked. This is not our best data center. This is across the entire fleet. And it's been that way for a long time. But we didn't just rest on making energy-efficient data centers and building energy-efficient computing systems. We then decided to try and make better use of the data that we're getting from our data centers. One of our engineers came up with the idea that said, if we could build a machine learning algorithm to analyze these volumes of data that we're gathering every day at the data centers, maybe we could find some insights that would help us drive the energy efficiency even further. That's exactly what he did. And then he partnered with our DeepMind group to basically make it production worthy. We employed that, and now we have the full ML system operating parts of our cooling systems at the data center fully autonomously, very safely. And of the energy consumption for the cooling, we've achieved about a 30% reduction in the energy consumption for cooling by having the ML system operate the data center cooling system for us. The way it does that, it's very simple. It's looking at about 19 to 20 independent variables in real time, and it's matching the cooling needs to the data center load at that time. So it's doing it in real time, and it's constantly adjusting, and this is basically far more efficient than humans could do it. And so we developed it, we tested it over many years, and little by little we made it fully autonomous, so now it's controlling the data center cooling. As I talked about, we have a strong commitment to powering the data centers on renewable energy. So we started our renewable energy and our zero carbon journey roughly in about 2007, when we decided that as a company, we were going to achieve a zero carbon footprint. And we did achieve that in 2007, and we did that primarily by buying very high quality carbon offsets. So we were just offsetting our carbon footprint. And we did that for 10 years. And in 2017, we, apart from celebrating the 10-year anniversary of being carbon neutral company, we also announced that we had achieved another major milestone. And that was that we are now buying enough renewable energy to offset the entire consumption of energy at Google data centers and Google overall. The entire enterprise. What does that mean? That means that we are the world's largest corporate purchaser of renewable energy. We have, since 2000, roughly 10-ish, we have signed over 30 large-scale power purchase agreements for solar and wind energy that is over 3.5 gigawatts of energy under contract. So we are now matching for every kilowatt or megawatt hour of energy we consume around all of Google, we are now buying at least an equal amount of renewable energy. And we are the first company of our size to ever achieve 100% matching of our consumption versus renewable. This is a little bit of our journey when we started in 2007. Frankly, I should have clicked on this slide when I was just saying all that stuff, but anyhow, like I said, we now have over 3.5 gigawatts under contract. We've spent over $5 billion on these energy purchase agreements. In 2017, as I mentioned, we had 10 consecutive years of carbon neutrality, and we matched 100% of our consumption. But as I talked about, we don't rest on our laurels, and so even that is not good enough for us. Because in order for us to truly take responsibility for our energy footprint and our impact to the environment and the climate, we need to be able to match our energy consumption with renewable energy 24 hours a day, 7 days a week. As you know, some of the grids in which we operate don't have abundant renewable energy on them. In some places, the regulatory environment doesn't allow you to go out and purchase your own renewable energy contracts. So in order to achieve that, we're going to have to come up with some creative thinking. So the team's been doing that. And one of the demonstrations of this is that in Taiwan, where the regulatory environment previously had not allowed corporate companies to go out and buy their own energy contracts and put it on the grid there in Taiwan. So we worked with the Taiwan Power Company and the Taiwan national government, and over a period of time of collaborating with them, we were able to get the Taiwan Power Act changed that allows us to buy renewable energy contracts and put it on the grid in Taiwan. So our first one that we did is pretty unique. These are kind of fish ponds where fish farm. They raise fish in these ponds, right? So we have a developer that is now building solar panels above these fish ponds. So now we have a solar pond or solar farm above a fish farm. And that's what we're in. It's right in the same local area as where our data center is. So that is helping us to green our operations in Taiwan and helping us basically take more accountability for our consumption in that local region. So this is the first of a kind in Taiwan. And by the way, when we make these agreements, we don't do it just for us. We make the policy so that anyone that wants to follow our actions can do that also. Another example, in Belgium, we did this solar farm. This is about 10,000 solar panels on our data center property. Normally, we would do these off-site where we could have larger installations. But in this case, this was a great way to match or offset our energy consumption for our office areas and our facilities, not the data center itself. That would be too large. However, in another part, in the southeast of the United States, in Tennessee and Alabama, we worked with the Tennessee Valley Authority to build one of the largest PPAs that has ever been done in that region. That's 1.5 million solar panels, 413 megawatts that are being built specifically for Google that will offset our consumption in that region for the foreseeable future. So we're going to have to work hard to actually make this a reality. 24/7 renewable energy, as you know, like I said, renewable energy is not available everywhere in the world. It's not available every day or every hour of the day. The sun doesn't shine 24 hours a day. The wind doesn't blow 24 hours a day. So we're going to have to get very creative with this. We've developed a tool that allows us to analyze at a data center level the consumption of the data center and match it to what the renewable energy generation is hour for hour so that we can see how we're doing. In some data centers in parts of the world where we don't have a lot of access to renewable energy, it's not matched very well yet. In other parts, we're over 65% matching today already. So we have a long way to go, but we think it's important enough to dedicate a team of resources to this initiative. And it's a long-term goal. I don't know when we're going to achieve it. It is arguably a moonshot, typical Google thinking. But in order to really take accountability for our footprint, this is what we have to do. This is, as I mentioned, this happens to be the data center in North Carolina, showing how on a day, hour-by-hour basis, we're matching with our renewable energy. So you can see that in some parts of the year, we are 82% carbon-free. Other parts of the year, we're 49% carbon-free. So it changes, of course, seasonally and hour by hour. But this is giving us the insights that we need. The really cool thing that we did, remember that ML system I told you about that was operating our data center cooling systems? Well, DeepMind and us partnered together to adjust that system and said, what if we apply that same type of machine learning to a wind farm? What would that do? Well, we developed jointly a new ML system that allows us to predict what the energy generation of a wind farm will be 36 hours in advance. Why is that really important? Because if you're a grid operator, the intermittency of renewables make it really hard for you to plan how much generation you need. You know what your demand is going to be more or less because you've got a long history of looking at your demand from your customers, but you don't know what the output of that wind farm is going to be tomorrow. Well, this ML system allows us to predict it with high degree of fidelity what it is. So now they can plan on that and put that into their base load calculations. We can better utilize the full output of the wind farm, which has resulted, now these are the early days, I don't know if this is going to be how it is always, I hope it's better, but we've already achieved about a 20% improvement in the value of the wind farm that this was done at, the value of that renewable energy. So I think there's a lot of hope here. Okay, and the third pillar is the circular economy. And our belief is that we should reuse and recycle and have a zero waste to landfill goal. We have achieved zero waste to landfill at some of our data centers, but not all of them. Today, across the entire portfolio, we're 91% diversion of waste to landfill. That means that only 9% of all of our waste, whether it's from construction or operations, is making it to a landfill. This required us to think about things differently, to come up with better reuse strategies so that we can take components that maybe aren't used for that particular customer, but use them for another internal customer. Like for instance, if search said those machines are kind of out of date for us, but some of our other internal services can still use them. So rather than just recycle them, we're reusing a lot of that. We're remanufacturing a lot of our servers with recycled components. And we're reselling some of our components as well, so that we're really diverting a lot of that otherwise would be electronic waste. And it's not just us talking about it, but a lot of other people have noticed our sustainability efforts. So we've been at the top of the CDP awards list for many years. We were given the Zayed Future Energy Award in Abu Dhabi a couple of years ago. So it's being noticed. It's not just we're doing it for ourselves, but we're doing it for all of you, all of our customers as well. Because now you know that the workloads that you run in Google Cloud are helping you achieve your own sustainability and your own carbon neutrality initiatives. So, this is a quote here from one of our customers, Etsy, their CTO, said that underneath their ecological goal, they want to be 100% renewable electricity by 2020. And that they know that all of their workloads that they're processing with us on Google Cloud are helping them to achieve this initiative because they are already being powered by renewable energy on our cloud. So, if we review our core principles for our data center program are around performance, availability, reliability, security, and an environmental responsibility, and a commitment to 100% sustainability. We truly are building the world's most sustainable cloud.